Hello class, welcome to Geometry Lesson 12.4, which is all about probability distributions. By the end of this lesson, you should be able to define probability distributions to represent experiments and solve problems. So the very first thing we're going to talk about is the difference between theoretical and experimental probability. Okay, so I realize that those are kind of a couple of big words, but you've already kind of been working with this, so it's not as scary as it sounds. So theoretical is kind of the in a perfect world situation. So if I think about the theoretical probability of flipping a coin 4 times, the theoretical probability means that I would get heads twice and tails twice, right? Because heads and tails, those are the only two options. So in a perfect world, they would, kind of like alternate or appear exactly the same amount of times. So theoretical, if it was flip a coin 4 times, that would mean I would maybe have like heads, tails, or any sort of combination where the heads and the tails happen equally. But I think if you were to try to flip a coin, you would realize sometimes you might get 3 heads and then a tail, or you might get all 4 tails. It just depends on how the coin flips, So that's really the difference between those two words. Theoretical is what the predicted outcome would be, the perfect world example, and experimental is what actually happens. And you've already worked with how to calculate those probabilities, so I'm not going to go into that because I think when you guys get to the homework assignment and you read the problems, you're going to be able to reason your way through it, and I can help you. What I want to spend more time talking about is something that you guys haven't worked with before, and that's called binomial experiments. Now, these are the more complex real-world probability things because, in all reality, how often do we flip a coin? Like, you probably flip a coin the most in a math class. It still happens in the real world, but not as much. So binomial experiments will get into more everyday real-world probability that's a little more complex. So in a binomial experiment, it's important to know that it consists of a fixed number of trials, okay? So it happens a certain number of times, and each trial has 2 possible outcomes. So kind of like if you're playing a basketball game, you either win or you lose, right? Because if it's a tie, you go into overtime until there's a winner and a loser, okay? So it's a trial with 2 possible outcomes, and they are independent events, and the probability of success is the same for every trial. Now, here in the second concept bubble is the formula that you guys are going to need. So you are going to need to memorize this. I realize that it looks really big and scary, but once you get used to using it a few times, I think you'll be able to remember it, and it won't be so bad. Right now, it just looks scary. We're going to do an example with it to break it down, okay? So it's the probability of having a given number of successes in a binomial experiment, and that is our binomial probability. So quickly jot down that formula, and let's try an example so it seems less scary. All right, so we have a grocery store gives away scratch-off cards with a purchase of more than $100. Okay, so you go to the grocery store, spend $100, you get scratch-offs. Okay, Terrell has 5 scratch-off cards. What is the probability that he has exactly 3 winning cards if each card has a 30% chance of being a winner? Okay, so everything up here is setting up the problem for us. Now, let's talk through the steps on how to solve this. So, step 1, is this something that can be solved using a binomial probability? So, first of all, Terrell has 5 cards, and they represent 5 trials, right? 5 times of trying to win. Each card is either a winning card or not. There's no in between. And then whether one card is a winning card does not affect that another card is a winning card. Okay, so these are all things that have to be true in order for it to qualify for binomial probability. And then we have the probability of success is the same for every trial. Every card he has the same chance of winning or losing. So this is a binomial experiment. Then step 2, find the probability of the 3 successes. So we use the formula, the big long N choose R times p to the r times 1 minus p to the power of n minus r. That's a lot of variables. Let's talk through what that looks like. Gives the probability of r successes out of n trials. So first of all, we've been doing this. This was yesterday's lesson in 12.3. We practiced combinations. So if I have 5 cards and I choose 3, how many options is that? That's 10 options, okay? So I already have that first number. So I would replace this with 10. Then what you need to know is n represents the number of trials and p represents the probability of it happening, and r represents the number of choices. So r is the number of picks, right? So I have 5 choose 3. That gives me 10. And then I'm going to replace what's the probability of this happening. We're told each card has a 0.3 chance of occurring. R is the number of choices I picked, which I chose 3 cards. And then you're going to multiply that by 1 minus the probability. So 1 minus 0.3 gives me 0.7. And then that's raised to the n minus r power. So remember, n is the number of options, the number of trials. Okay, so there's 5 cards total. So I would do 5 minus 3, because that's how many I'm using. And that's how I got that 2 up there. Then when I plug this into my calculator, I get 10 times 0.027 times 0.49, and I end up with 0.1323. So the probability of having exactly 3 winning cards is about 13%. Okay, so I realize you still might be confused, but what I want you to do is I want you to see, first start and write down what does n equal, what does r equal, and what does p equal. Once you have that, it's just plugging things into a formula. You guys are great at that. If you need help with it, ask for some assistance, and I'm happy to help you. But what I want you to do is I want you to solve this problem, except we're going to ignore this part right here. Sorry, I meant to erase that before the video I started recording. Okay, so to the nearest 1/10 of a percent, what is the probability that Terrell has more than 3 winning cards? I'm not really worried about you typing an explanation, because if you actually do it correctly, that tells me you know how to get there. Okay, and then I just took the information from the last slide to help you remember. So go ahead and try to solve this. If Terrell has more than 3 winning cards, that means he could have 4 or he could have 5. So go ahead and try to figure this one out. Good luck. All right, for this question, hopefully you first started by finding the probability of getting 4 winning cards. So you said 5, not cards, sorry, tickets, or cards. They are called cards, my bad. Out of 5 tickets, you chose 4 that were winning. You had a 0.3 chance of winning, raised it to the 4th power, and then 0.7 to the power of 5 minus 4. So when you multiply all that together, you found that the probability of having 4 winning tickets was 0.02835. Then you found the probability of getting 5 winning tickets out of 5. And when you multiplied that together, you ended up with 0.00243. Then for the last part, you could either have 4 or 5, and since it's an or statement, we are going to add those 2 numbers together. So you end up with 0.03078, which if we are rounding to the nearest 1/10 of a percent, as it says up here in the directions, that would be 3.1%. Okay. I realize that these questions can be a little tricky, but all of the questions that are on your homework, I promise, have the click here for question help, and it'll walk you through even more if you forget how to use this formula, or you can come see me, you can ask friends. So many options to get help. And here's your concept summary for this unit. If you have any questions at all, please do not hesitate to reach out for help. I'm more than happy to assist you. Have a great day.